All right, we're going to end this lesson by figuring out what would be a better measurement, volume or surface area when answering the question that we are posed here. So we have a forester. Forester surveys giant sequoias by gathering data about the heights and circumferences of the trees. So this forester has 3 trees, tree A, tree B, tree C. We can see how tall each tree is. So A is the tallest, then B, then C. But they do have circumferences, different circumferences. And when it says measured at 4.5 feet, that's 4.5 feet off the ground. That's where they measured the circumference because, trees kind of taper as they get toward the top. So you just want to make sure if you're comparing circumferences that you are measuring from kind of the same spot on each tree. And that's what that shows us. Okay. So should the forester use surface area or volume to describe the sizes of the sequoias? All right, so surface area, if you're thinking trees, would be kind of like if we were talking about the bark, right? The surface. How much bark is there on a tree? That's what a surface area would give us. Volume is what would tell us about the size. How much space does a tree take up? So should the forester use surface area or volume? The forester should use volume to determine the size of the tree. So what are the sizes of the trees shown? So I think that's why we had this first question. If you're asked this, what are the sizes of the sequoias shown? We're going to find volume. We wouldn't look at surface area because that doesn't tell us the size of a tree. It's the volume that tells us how much space it would take up, the three-dimensional size of it. Okay, so and then we're going to rank them from the largest tree to the smallest tree. We got a little bit of math to do, guys, so why don't we just look at one tree at a time. So we'll start with tree A. So volume is area of the base times height. These trees, we are going to look at them as cylinders. So there's tree A. We know the height of tree A is 270. But we don't know the radius. We do need the radius in order to find the volume, but they told us that the circumference. So we're going to use our circumference formula to help us find the radius. So circumference is equal to 2 pi times the radius. If we know the circumference is 101, we're going to replace the circumference with 101 equals 2 pi times the radius. And then to get the radius, we'll just do a little bit of math. Let's divide by 2 pi. So when we divide by 2 pi, our radius is equal to 16.1. Well, now we can find the volume of tree A. Area of the base times height, but our base is a circle, so area of our base is pi r squared times height. So pi times, we just found the radius, is 16.1 squared. And then the height we said was 270 feet. When we multiply that out, we get a volume of 219,870 feet cubed. All right, let's see how the other trees compare. Tree B. Tree B looks something like that. Tree B is not as tall. It's only 258 feet tall, so there's our height, and it has a circumference of 109. So again, we're going to use our circumference formula, 2 pi r, to find the radius. The circumference is 109 equals 2 pi times the radius. To find the radius, we can divide both sides by 2 pi, and our radius for tree B is, we'll round it to 17.3. Now we can find the volume of tree B because it's a cylinder, pi r squared times the height. So pi times the radius is 7.3 squared. times a height of 258. And we multiply that out and we get 242,584 feet cubed. So even though tree A was taller, tree B actually has a greater volume. It takes up more space. And that's because it's probably it's a little bit, the radius is a little bit bigger, right? So it's a little bit of a wider tree. All right, last one, tree C. What do you guys think tree C is gonna be? So again, here's my cylindrical tree. This height is 248, and they told us that their circumference is 106. So circumference equals 2 pi times your radius. Remember, we're using our circumference to help us find the radius so we can plug that into our volume formula. So their circumference of tree C is 106 times 2 pi r. Let's divide both sides by 2 pi. So the radius of tree C is 16.9. So the radius is between tree A and tree B, but the height, it's also the shortest tree of the bunch. So let's see how this volume works out. Volume is pi r squared, so 16.9 squared, times the height, 248. When we calculate that, we get a volume of 222,523 feet cubed. By the way, these are pretty big trees, right? So that's why these volumes are so big. And we were asked to order them by size from largest to smallest. So tree B, that is our largest tree. Then we've got tree C and then tree A. So the tallest tree actually was kind of the skinniest, ended up having the least volume. So there we are ordering largest volume to smallest volume.